Let's get to deployment. Buzzword central, software as a service, service-oriented architecture, public cloud, utility computing. At one point, when we had just come out with a textbook several years ago, somebody saw a flyer for it at a conference that Dave Patterson and I were at. And the title of the book is Engineering Software as a Service, an Agile Approach Using Cloud Computing, which we actually think is a fair description of what's in the book and what's in this class. And I guess the person there didn't realize that we who were standing by the book were the authors. And he said, wow, it seems like the author of this book just wanted to get every possible buzzword into the title. All right, thanks. Anyway, that wasn't the goal. But I think it's kind of a done deal right now that so much of the interesting software that we use has a combination of a client part and a cloud part. The client part is increasingly something you carry with you. It used to be the client part was a PC on a desk that didn't move around. But today, the client part is more likely to be something that runs on a smart home device or on a watch or tablet or phone or even an internet appliance like the Roku box. So we're going to talk about deployment and how we got to this kind of architecture for software as a service. This no longer has to be said. I think in the sort of 2000s, we still had to say software as a service has so many advantages over shrink-wrapped software. Depending on how old you are in this audience, you may or may not remember a time when there were stores where you could buy software and it came on CDs or floppy disks, and you would take them home and you would put in 50 disks one at a time and you would install stuff, and then it wouldn't work because you had the wrong version of Windows or Mac OS or whatever. And then things got better because now you could download things over the internet, but you would still have to install them, and you would still have a lot of these problems. And now a lot of these problems have just sort of gone away because those applications have moved to being software as a service, to being in the cloud. So think about using Google Docs versus Microsoft Word or Google Spreadsheets versus Microsoft Excel. Not that this is a Google versus Microsoft thing, but Google sort of got there first. Sorry. But in that scenario, there's nothing to install other than having a web browser. There's no issue about, does your hardware support the app? Do you have the right version of the OS? Those things just sort of go away. Your data is now stored in the cloud. And believe me, I trust Amazon to store my data way more than I trust me to store my data. If I, have an accident in my house or something, I might lose my computer. I might even lose my backup hard drive. But somewhere in the world, and please don't ask me where, there are spinning disks with copies of all my stuff. And that gives me warmth and I can sleep at night. It also means that I can give other people access to that data. We can collaborate on authoring a document or working on a spreadsheet together or whatever. Much harder to do if each person is sort of stuck in their own little silo. If the data set is large or if it changes frequently, it's actually simpler to have one copy that's in the cloud rather than having multiple people, everyone trying to keep their copy in sync. When the app gets upgraded, it gets upgraded in the cloud. So I don't have to download anything in order to take advantage of the upgrade. And in fact, if I'm the developer and I want to roll out a new feature, but I'm not sure if it's going to work well or if people are going to like it, I can just sort of randomly say, I'm going to pick 1% of my users and just try it on them and see how they behave, see how their behavior changes, and decide based on that if I want to pull the feature or if I want to roll it out the rest of the way. Can't really do that with software that has to be installed. And I think by now, like I said, I think this battle is over. Even what people used to think of as desktop productivity apps like word processing and spreadsheets, all of that stuff has now moved to a software as a service model. Today, this is pretty obvious, but in the early 2000s, it wasn't quite so obvious. And in particular, if we want to take advantage of things like don't repeat yourself, reusing software components, there's a question of what that means when you move away from a model where the software is assembled and distributed, and when you move towards a model where it's just deployed in one place. So what does reusability and software design and architecture mean in a software as a service world, if in fact that's different from what it would mean in the old world of shrink-wrap software? This man was remarkably ahead of his time in sort of publicly shouting out about this. You don't recognize him? That's Jeff Bezos, the CEO of Amazon. And according to Steve Yegge, who had been an Amazon engineer, he was subsequently a Google engineer. I don't believe he's at Google anymore. But he wrote this long, interesting blog post, and you can find a link to it in the textbook, that said Jeff Bezos realized long before the vast majority of Amazonians, that's what they call Amazon engineers, that Amazon needed to be a platform. So let's take that apart and ask, what does it mean Amazon needs to be a platform? Well, if you look at the way that Amazon basically originally worked, and it's actually the way that most early websites and e-commerce sites worked, as sort of plain software as a service, if you were to look inside the app, what you would see is that there's different subsystems. So for example, there's a place where people can write reviews of products. There's a place that keeps information about users, like your contact info and billing. There's a place that tracks what has actually been ordered so it can do fulfillment. And for various reasons, those services need access to each other's data. So for example, when you're buying something, you might want to read reviews, you might want to make a purchase. That means that the purchasing system has to know about you, but it also has to know about what's happening in fulfillment. If you want to write a review of something, the review subsystem has to be able to match up your data with the thing that you write. So it's sort of obvious that these systems have to talk to each other, but from the outside, there's really only one set of APIs into the service, which is, this is a big e-commerce site. And what Jeff Bezos said is actually, no, here's the way that it should really work. Every one of those subsystems should be independent in the sense that the only way to communicate with it is through its own mini API. So there is still a review service. It has its own data about reviews. There is still a user service. It still has its own data about user profiles. But if you wanted to combine the functionality of those services, you need to do it by asking them to do things for you through their APIs. You are no longer allowed to reach directly into the data storage of, let's say, the review system from the user profile part of the code. The only way to get things done is to ask another service to do something for you through that network API. This is basically what a service-oriented architecture means. It's really that simple. Each one of the subsystems does one very specialized thing, and the only thing that it exports to the rest of the world is an API, basically a list of operations, or in the parlance we're going to use in this class, a list of resources and operations that you can do on those resources. And by the way, in 2002, this was kind of a controversial thing, but the nice thing about being CEO is basically he wrote this edict and he said, do it this way or you're fired. Like, this is really important to Amazon. And he even said, again, ahead of his time, not only do you have to encapsulate your services this way, you have to assume that someday your mini API for each service is going to be exported outside of Amazon to the rest of the world, right? And guess what? That's the idea that basically became AWS. So Amazon runs a lot of their own infrastructure on AWS for a reason. It was designed to essentially have every little microservice have its own exportable API. And that was pretty forward-looking in 2002. So now, if you wanted to, you can imagine somebody who's not part of Amazon creating a brand new app, let's call it the favorite book service, which finds its own way to munge together information about reviews and information about people. And it's not something that Amazon provides. It's an API-based service. It's a third-party service that uses internal functionality from different Amazon microservices. A very early example of this that was super popular was when somebody did a mashup of Craigslist, the apartment listings portion, and Google Maps, which at the time was relatively new. And they used the APIs of both of those services to show a map with all of the apartment listings on it. Again, today, that sounds like, well, of course, why wouldn't you do that, right? But somebody had to be the first to do it. And the idea behind service-oriented architecture is each little service should have an API that is externally visible, that advertises what it can do, and that anybody can call. That's it. So what do you run all of this stuff on? Well, again, in the early 90s, it wasn't clear because these services were just evolving. What was clear really fast is that when software as a service became popular, there were three important things that the hardware would have to do. First of all, users have to be able to communicate with the service. The internet was getting built out. More people were starting to get broadband. So the communication part, that's not actually something that we as software as a service developers really control, but it had to be there. Scalability. This one's pretty important. A service that gets popular fast needs to be able to add capacity fast. A service that gets popular and then gets unpopular wants to be able to ditch capacity and not spend money on it. So before, you sort of had to provision as much hardware as you thought you might ever need, which if you're a small startup and you don't have a lot of cash, can be pretty intimidating. And of course, you want your users to depend on the service. You want it to be up and running and functioning correctly as much as possible. So how do you achieve these goals? Well, today, the answer is sort of obvious. You have big clusters at the scale of warehouses. But in the late 1990s, this was all done on supercomputers. As late as 1996, the largest search engine called Alta Vista at that time essentially ran on a big honkin' supercomputer. And if they wanted to add more capacity or make the index larger, they would have to replace that big honkin' supercomputer with an even bigger and more honkin' supercomputer. It's called a forklift upgrade, or it used to be. But by the late 2000s, it had become clear that there was a better way to do this, which is build data centers that have tens of thousands or even hundreds of thousands of essentially commodity PCs. PCs built out of more or less the same hardware that was available commercially that people would buy sort of to own personally. And the idea was that you could have an enormous economy of scale because you don't need that many operators to keep an eye on a lot of machines that are all identical. So it pushes down the cost of hardware because you're using the same components that are used to build hardware for consumers. You're not using exotic supercomputers. And it pushes down the cost of operations because you don't need as many human beings as long as there's sort of a recipe for how these things are provisioned. You get scalability because if you need more capacity, you just add more PCs. Of course, all of this assumes that the software architecture is built in such a way that just by adding more PCs, you can add capacity. And we're going to come back to that when we talk about the three-tier architecture and what the different tiers mean in terms of how they scale. But it also surprisingly means that you get dependability because it's probably fine if you have thousands of PCs. If a few of them are not working at any given time, you just keep, sort of eject them from the system, unplug them, and then somebody comes around with a wheelbarrow and they replace them once a week or something like that. So always having some spare capacity on tap means that it's okay for a few of them to be broken at any given time. And sort of the physical manifestation of this that I think Amazon was the first in 2007 to deploy something like this is what came to be called utility computing or public cloud computing. Utility computing is actually a name that really goes back to when time sharing was invented in the late 1960s. And the idea is that, when you pay your electric bill, you get a bill that says, here's how much you use. It's like a meter reading. And all you pay for exactly what you used, not for how much you could have possibly used. So the idea that you could pay for computing this way, that, previously you had to buy as many computers as you thought you needed. And if you weren't utilizing them all the time, that was on you. Now you pay for exactly what you need. And sort of, for the first time in history, if you wanted 1,000 computers for an hour, that would cost you the same as having one computer that you would use for 1,000 hours. That had never been true before. And that was a fundamental change that happened around 2007, which, by the way, if you're a startup, this is great because it eliminates your capital costs. If you're a software startup today, you probably are going to purchase zero hardware other than the laptops that your team uses. Because all of the rest of it, not only can you run it in the cloud, you can run it based on what you need. When you're doing your stealth development, you're using a couple of Amazon instances. When you launch your product and millions of people flock to you, you can add capacity as needed. And when the honeymoon's over and people move on to the next great thing, you can take the capacity away and move on to the next startup. So this is the world in which we're privileged to live. It's great for innovation. And the story of the evolution of frameworks in software as a service is exactly this. It's how do those frameworks allow you to easily develop software that exploits this incredible new model of computation. So that's where we're going to go next.